you absolutely need to know the entire unit circle. Okay? So the first thing I want to say is, with the unit circle, you need to know two things on it. You need to know all of the special angles that show up on the unit circle, and you need to know the ordered pairs of each point on the unit circle. Okay? To learn the angles of the unit circle, all of them are angles of pi over 12. People don't always realize that. They're all pi's over 12. What I do is I take and divide, so remember this is the angle pi here, and so then I break the top part into twelfths. I don't write these as part of my unit circle because 1 pi over 12 isn't a helpful unit circle angle. Okay? But I would do that, and I'd have a total of 12 of them, and then if I go all the way around, I've got a total of 24. So I guess you could also say I'm dividing this into 24 sections, but it's 12 in the top, 12 in the bottom. Okay? So I won't ever put these tick marks on a unit circle, and I'll erase them here in just a second, but let's just run through it. This is 1 pi over 12, so then what would this be? 2 pi over 12, but 2 pi over 12 reduces down to pi over 6, right? And this is 3 pi over 12, which reduces down to... Everyone tracking with that? Okay. This would be 4 pi over 12. Okay, so I'll write that one. That's 4 pi over 12, but again, that reduces down to pi over 3 when you simplify it. Okay. I won't write 5 pi over 12. This is 6 pi over 12, but that's really the angle pi over 2. Okay. So, for example, if I point to this angle right here, I need you to know that this angle right here is 5 pi over 4. There are some patterns that you can observe in this. First of all, notice that this is called the unit circle. It's called the unit circle because the radius of this circle is what? It's 1. The radius of this circle is 1. So this ordered pair right here is the ordered pair 1, 0, right? This would be the ordered pair 0, 1, right? Okay. So anyway, what I want you to notice is that the angles that are closest to the x-axis, not on the x-axis, but closest to the x-axis, are your pi's over 6's. So this is pi over 6. This is just a little bit less than a full pi, so 5 pi over 6. This would be 7 pi over 6, and then this would be 11 pi over 6. Okay? If you can't remember that, you could count all your 12ths, but that'll take you way too long, and you definitely can't do that on an exam. You've run out of time. Okay? Notice also that your pi's over 3's are closest to the y-axis. So this is this is pi over 3. This would be 2 pi over 3. Down here I would have 5 pi over 3. I feel like I did that wrong. 4 pi over 3. And then 5 pi over 3. So notice, so again, what I'm saying is your pi's over 6's are closest to the x-axis, your pi's over 3's are closer to the y-axis, and then who's in the middle? All of your pi's over 4. Okay. Any questions on that? So of the things you need to know, be able to do very quickly, that is step 0. Okay? Know all of the angles on your unit circle. Okay? Now, for each one of these that I've marked on here, you need to know the ordered pairs. Okay? I've already listed, let's just say this. I didn't say this. This is the angle 0, which is the same as 2 pi, which is the same as 4 pi, 6 pi, etc., right? Okay? I already labeled that as pi. It's also minus 1 pi, minus 3 pi. It's all the odd multiples of pi. But you have some points that are very easy to spot on the unit circle, and sometimes people forget about them. Okay? So the pi's over 2's and the pi's are the easiest ones to find the ordered pairs for. So just go on the fact that it is a unit circle, and we're talking about the xy axis. Okay. This next step is how I learned the unit circle. I don't know if it's the best way, but it's the way I teach it because it's the way I learned it. Okay. I have 3 little phrases that I've memorized. Okay. So I'm gonna let me zoom out. It's too big. Let's go to 100. So the 3 phrases that I've memorized is that a lot is equal to the square root of 3 over 2. Okay, so I tell myself a lot is the square root of 3 over 2. Same is the square root of 2 over 2, and a little is 1/2. Okay? Notice that all 3 of these are fractions over 2. And in fact, there's even more of a pattern if you remember that 1 is the same as the square root of 1. So it goes going from the lowest up, square root of 1, square root of 2, square root of 3. Absolutely, got to know those.
Is there an actual square root of 1 though?
Yeah, it's what number times itself gives you 1. Yeah, so we don't write the square root of 1, but there is a pattern happening there. So that helps you remember what's going on. Yeah, great question. So this is how I find my ordered pairs on the unit circle. Let's suppose I was interested in this point right here. Okay? And I'll let you decide how cluttered you want your diagram to get. Okay? So what I will do is I'm going to draw a triangle to that point. Okay? So if I start at the center, how do I get from here to here? Well, I'm going to go along the x-axis. How far am I going to go along the x-axis? I'm going to go a lot. Then what am I going to do? I'm going to go up the y-axis. How far am I going to go up the y-axis? A little. So what is this ordered pair right here? It's the square root of 3 over 2, comma, 1/2. Okay? Let me do another one. Okay? So I'm going to draw this triangle right here. And again, at this point, I'll let you decide how cluttered you want this to get. Okay. I made it kind of big, but maybe not big enough. Okay, so how did I get from the center, from the origin, to this point? Well, I'm going to go out the same distance that I go up. So I'm going to call this the square root of 2 over 2, comma, square root of 2 over 2, because it's same, but now I got to be careful of the sign, S-I-G-N. Okay? I got to be careful of the sign because I didn't go to the right the same distance. I went to the left. So what sign goes in front of this? A minus sign, but the y value is still positive. Okay. Let's do another one. Let's just do this one right here. Okay. How did I get here? I went back a little, and then I went down a lot. All right. By the way, if I did this one right here, you don't really draw a triangle. It's hard to see a triangle because it's a 180-degree triangle. Okay. But then again, finding the coordinates there is straightforward because it's -1, comma 0. So you don't need my little gimmick to get there. Yeah, Karina.
Also, the way that helps 1, 0, so between those two, cosine is going from 0 to 1, so then it's 1/2 root 2 over 2 the same.
Yeah, so what Karina said here is that if I put this ordered pair up, I've got radical 2 over 2, radical 2 over 2, and if I put this one here, I'd have 1/2, comma, square root of 3 over 2. So notice how these are laddering, the x coordinates are laddering down. Radical 3 over 2, radical 2 over 2, 1 over 2. Whereas the y coordinates are laddering up, 1/2, radical 2 over 2, radical 3 over 2. Okay, so there's a nice pattern there. There's lots of patterns in this. It's where all your trig identities come from, all the patterns in this. Okay. So anyway, I need you to being able to identify those coordinates lickety-split. Okay? That's step 1. Okay? So step 0 is make sure you can do all the angles. Step 1 is make sure you can do all of the ordered pairs on the unit circle. Okay? Step 2 is knowing how do you get actual trig values from this. Okay? So the sine of the angle theta we've memorized is the opposite over the hypotenuse, correct?
Sure.
Okay. Well, first of all, what is always my opposite? Or what is always my hypotenuse on the unit circle? Always on the unit circle, my hypotenuse is 1. So we don't even really think about it on the unit circle. Okay? Then let's say I was thinking about this blue triangle right here. Well, this is my angle, right? There's my theta. So my hypotenuse is 1, this length right here. And then what is the length of my opposite? It is simply the what coordinate? The y coordinate. Notice the y coordinate tells me the height of this triangle. So this is y over 1. Okay? And in fact, we'll always just say that on the unit circle, if I want the sine of the angle, I just take the y value. Okay? The cosine of the angle is just then the x value by the same argument. It's actually the adjacent over the hypotenuse, but the length of the adjacent is simply your x coordinate, and the hypotenuse is 1. Okay? So step 2 is being able to find the sine and cosine for any angle. Step 3 is answer the question, depending on what the question is. Okay?